Hi, this video is a lecture taken from my online course about data engineering on Microsoft Azure, and I hope it helps you learn more about data engineering. In the last lecture, we executed our pipeline together with the data flow. And as a result, as you can see from Azure Storage Explorer, we then have a lot of small files. The files are small because if you take a look at the size columns inside Azure Storage Explorer, you will see that these are quite small files. And to understand why this is happening like this, or why a data flow produce file like this, we must go back into the definition of a data flow. From the data flow page, we can read the definition of a data flow. And we can see here that data flows allows data engineer to develop data transformation logic without writing any code. We already saw how this works. However, you can see here that the resulting data flow are executed as activity between Azure Data Factory pipeline that uses scaled out Apache Spark cluster. And this is the most interesting part of this documentation, which means whatever we do on the Data Factory page, we can do the transformations, aggregation, and everything else. At the end, these transformations are going to be translated into source code, into Apache Spark source code, and executed on an Apache Spark cluster. Apache Spark is a cluster computing framework, which means it runs on multiple nodes or servers to achieve great performance. The data are then read into memory in the form of data frame. So let me show you how this looks like. The data flows that we created using Azure Data Factory are translated into Apache Spark source code. Apache Spark is a cluster computing system, which means it can run on multiple machines to achieve great performance. Given the information that we store in the linked service, what then happens behind the scene is that the source code running on the Apache Spark cluster will read data in the form of data frame and store them in memory on each node in the cluster. The data frame holds data in the form of partitions to allow parallel processing. So again, a data frame is similar to a table in a relational database. A data frame has columns and rows, and a data frame holds data in form of partitions in memory. And at runtime, the following then happens. One processor or one core will process one partition, and this is what we call an Apache Spark task, which means one CPU core processing one partition. And when the processing is successful, it produces one file and then moves on with the next available partition. And because this is a parallel processing system, what then happens, or what really happens, is that all the CPU cores will be working at the same time, and we will have something like that where all the 4 CPU cores are processing the data at the same time and producing files. And when a processor or a core is done processing one partition, it then moves on with the other one. And just in case an error occur, of course, you will also have no file for that. So this is how Apache Spark generally works. Apache Spark will read data in memory into the computer node that are used to run the computation, and from there it will process the data in parallel and produce multiple small files, also known as part files. This is exactly what you are seeing here. We have all these small files because we have multiple processors running in parallel processing partitions files. And of course, if you open it, you will then see the result like this. We can also then go back into the data flow. If you select the pipeline, select the data flow, and then go to the settings. Here is where you can decide the size of your cluster, how many CPU cores we need, or how many nodes we need in the cluster to process the data in general, the type of each node. Do we want to do general purpose computing, memory optimized computing, or compute optimized operations? And because this is Apache Spark is most suited for memory optimized operation, because Apache Spark read all data in memory and process the data in memory. And this is the reason why you may have a lot of small files after running a data flow in Azure Data Factory. Also, one last thing that we must learn about the pipeline is that we can run a pipeline based on event or triggers. Let me show what I mean by that. Up here, you will see this option, Add Triggers. If you click on Add Trigger, you can trigger it either now or you can create a new trigger. If you go to New Trigger, select here, you can click on this plus sign to add a new trigger. And then you will land on this page where you can create new trigger. We can also do the same thing over here. If you go to Managed, you then have Triggers. You click on Triggers. Now you can see all the triggers available in your data factory. Then you can click on New Trigger and you landed here again. There are multiple types of triggers. There are triggers that will invoke a pipeline based on a clock. This is a scheduled trigger. There are also triggers that will operate on a periodic interval. This is what we call a tumbling window trigger. If you select that, you can decide the recurrence interval every 15 minutes, every 30 minutes. So here you have the schedule one, where we say it should run every 10 minutes, but it does not have a state. The tumbling window one, it have a state. And we also have storage events triggers, which means you can decide to start the pipeline after a CSV file was created in a specific container. And we also have custom events that are actually in previews. In the next section, we will learn how to use these three types of triggers. For now, it's enough to know that they exist. And you can go ahead in the documentation and start reading about them. In the next section, we will then apply these different types of triggers. If you enjoyed this video, I think you will also like the entire course. The course covers multiple Azure services that you can use to perform data engineering. For example, you will learn how to build a data pipeline using Azure Data Factory, or how to use Azure Key Vault to secure access to your data. Also, with Azure Synapse Analytics, you will learn how to build a modern data warehouse in the cloud, or how to run Apache Spark code using Azure Synapse Analytics. And it covers other topics such as Azure SQL databases and much more. So check it out using the link below. Thank you.